Now let's look at some ways to check the input to the gap generator. Set this to 125 magnification. Okay. Now here we're in neutralization only. And again, meaning power is only applied for 1/2 of each cycle. And the input volts and amps are measured. The coil side of the relay, I'm checking it in DC in and DC out. And here we have 104.92 watts over unity. That means 206.18% of unity. But look here. The maximum amps input for the first half of the cycle, and that's the only time power is applied, is 8.4. And the average amps input is 4.8. But now look at this. The maximum amps input for the second half of the cycle is 9.6. And 4.4 average amps input for the second half of the cycle, and yet there is no power applied during that time in the cycle. Now, here I have the trigger set on channel 2 with AC coupling. And channel 1 menu AC coupling, channel 2 menu AC coupling. Now the power supply states that there's 9.2 amps going to it. And yet the 7.5 amp fuse will not blow. But I can believe this will operate on a 7.5 amp fuse. And I feel this is how the input should be checked. And you can see the video. And I'm speaking of the test done on the 7.5 amp fuse. Pretty simple. I had to find a way to check this to where these numbers here would fall within the specifications of a 7.5 amp fast acting fuse. Now let's look at the scope here. Now this is just showing one cycle. But here's the voltage input and the amps input. And here's the voltage output. And here's the amps output. But note right here, the voltage input is set to 50. And yet it's only going up, looks like maybe 20 volts on the first half of the cycle. But on the second half of the cycle, it's going down probably to 30 and back up to about 20 right here. And the amps are like this. This is actually what's happening with this device, where I'm switching it back and forth. I'm really not switching this back and forth, I'm just turning it on and off. But what I think this is right here, from this point right here, there's 10, 20, 30 milliseconds is right here. I think this is this voltage here in this last half and the amperage here in the last half of this cycle is coming from the back EMF from the coil and the magnetic action going to and from the coil from those magnets. Of course, that's just my opinion. Now let's look at Well, just for a second here, let's look at right here again. Remember, this is 104.92 watts. And I haven't removed that input from the last section where there is no input being applied. But we'll look at it right here. Now, I'll increase that to 125%. Okay, this is the same test. And the only difference here is that, let me get this in here where you can see it. Right at the bottom, is the last half of input is removed. See, there's only power applied for half of the cycle. You see how the watts over unity went up? It's 162.02. That's 488%. 488.39% of unity. Now, this is with no moving parts. The gap generator with no moving parts. And that's about it. Let's look at how I did this. I'll show you again how I removed the last half of the input. So let's just go over here and we'll scroll down. I think I need to move this over a little bit. And right here's, there's 2,500 readings here. I got to find that one cycle. So we're going to go down to 30 milliseconds, or not, 0 milliseconds, where the time is 0. Yeah, right there we are. Your start of the cycle at 0. So you can see here's the voltage coming in, here's the amperage coming in. Over here's the voltage and amperage going out. So we're going to scroll on down here to 30 milliseconds. That's half of the cycle. We're getting there. Okay, here's half of the cycle at 30 milliseconds. And just after that, I put the voltage and the amperage input to 0 because I'm applying no power there. And I continue on down here all the way to 60 milliseconds, which is the end of the cycle. Didn't know 60 milliseconds could be so long. Yeah, here's the end of the cycle, 60 milliseconds, and then goes right back to where it was reading. So anyway, I believe this to be the correct way of checking it.